So we will embark on something different today, and what we shall be able to maximize on today is trying to look at some of the chemical equations you can be able to write down, and as well be able to look at how different compounds can also get formed chemically. And we shall just use a good number of examples that are commonly able to get found in our daily discussions in as far as this subject is concerned. So we shall begin with this first example, and I have zinc chloride. Zinc chloride, that's our first example. And I want us to write the chemical equation of that zinc chloride. And writing the chemical equation of this zinc chloride will actually involve us looking at two very important parts here. Number one, we shall first be able to come up with the oxidation state of zinc. And for your information, students, there are some elements in chemistry which are not found in the first 1 to 20 category. So it's very difficult for us to come up with their own oxidation state. So for us to be able to clearly be able to actually write their corresponding compounds, or what they can be able to form in as far as combined with other compounds are concerned, we can decide to actually just make this summary. And the summary can be, look at this: zinc, lead, copper, and iron as well. Look at that. They have the following oxidation states. They have these oxidation states. So they all react by losing 2 electrons. And this can react by losing 2 electrons. This can react by losing 3 electrons. And we also even have this copper 1 that reacts by losing 1 electron. So if you come across these elements, just know that their oxidation states can be as far as what we've just written here is concerned. So you can either find zinc 2. Look at that. That is zinc 2 to mean that it has reacted by losing 2 electrons. Because I told you in my previous discussion that zinc is a metal, and being a metal, it has to react by losing. And of course, for your information, by the way, all metals react by losing. If you find any element with a positive charge as its oxidation state, that must be a metal. It must have reacted by losing an electron or electrons. So zinc has reacted by losing 2 electrons. Lead has reacted by losing 2 electrons. Copper has reacted by losing 2 electrons. Iron has reacted by losing 2 electrons. Iron as well has reacted by losing 3 electrons. And copper here has reacted by losing 1 electron. So I can just come here and be able to say that now the chemical formula of zinc is capital Z small n, and its oxidation state is 2 positive. Okay. And chloride from the word chlorine. And chlorine, if you remember very well, we did this in our previous video, and I told you that chlorine is number 17. So it must have an electron arrangement of 2 to 8 to 7. It having 7 electrons in the outermost energy level, it ends up reacting by gaining 1 electron. So it ends up having a negative charge as its oxidation state. I have told you time in, time out. If you see a positive sign, that means it must have reacted by losing. If you see a negative sign, that means it must have reacted by gaining. So chloride comes from the word chlorine, or comes from the element chlorine, capital C small l. The atomic number of chlorine is 17. Its oxidation is negative because it reacts by gaining 1 electron. And of course, it has to actually come from this electron arrangement. And the electron arrangement is 2 to 8 to 7. So 2 plus 8 plus 7, that is 17. So 2 to 8 to 7, 7 electrons in the outermost energy level, it must react by gaining 1. So gaining is negative. It develops a negative charge on top of its chemical formula. Okay, so let's proceed forward. We want now to come up with the chemical formula of this zinc chloride. I told you there must be the interchanging of the states that appear on top of the chemical formula of those elements. So the 2 drops here, and the 1 can drop here. Of course, if it's just 1, you don't even need to drop it. So you'll end up having zinc. You don't need to put here 1, right? Then the Cl and the 2. That becomes zinc chloride, or zinc 2 chloride. I may tentatively be able to get another example such as ammonium phosphate. So ammonium and phosphate are not elements. They are not metals. They are not nonmetals. They are radicals. Previously, I told you a radical should be a group of atoms, and those atoms must be able to exist as a unit, and they must as well react as a unit, but they must have a net charge. Ammonium is captured as this chemically, a group of atoms that are able to exist and react as a unit, and they have a net charge which is positive. Phosphate, look at that. A group of atoms, phosphorus and oxygen, that are actually existing and reacting as a unit, and they have a net charge. Why do we say they exist and react as a unit? That means when they are combining, they don't separate. They come as a whole. So they exist, a group of atoms. How many atoms are here? Two, nitrogen and hydrogen. So a group of atoms that are existing and they will react as a unit, as a whole, and they must have a net charge. Again here, phosphorus and oxygen, a group of atoms that are existing and reacting as a unit, and they must also have a net charge. Right. So let's do the interchanging of these oxidation states. Then you can be able to come up with the chemical formula of that compound called ammonium phosphate. So we shall say NH4. Look at that. And because the 3 drops here, we can be able to put this in brackets and then put 3 outside. Yeah. And you can be able to say PO4, phosphate. So that reads ammonium phosphate. Ammonium phosphate. Correct. I may give another example, and I can use this example. I can talk about sodium, yes, sulfite. Sodium sulfite. There is a difference between sulfite and sulfate. So we'll begin with the sodium. Sodium is a metal, it's not a radical, so it can actually exist as an ion. How? It must first be able to end up losing 1 electron. How? Sodium is number 11. So the electron configuration is 2 to 8 to 1. So it has to react by losing 1 electron. So if it loses 1 electron, this outermost electron, it ends up having a chemical formula of capital N, small a with a positive charge on top of it. Then the sulfite, it is SO4, and because it is I, we'll alternatively be able to write here 3 because it's not sulfate. Then you can write 2 negative. So sulfite. We'll drop the 1 here. We shall drop the 2 here. So what do I have at the end of the day? I'll have Na with a 2 from this part. Then SO3. Okay, that is it. So those are just examples of the compounds you can be able to form in relation to what the question has actually asked you to do. And that tentatively has to end up giving you an upper hand in trying to understand how you can be able to write chemical equations. So this way you're supposed to actually write chemical compounds. And if someone asks you to write chemical equations, what are you supposed to do? Chemical equations. And of course, balancing those of those chemical equations. You can use this example. Let me say, for example, sodium plus water. We always begin with what we call a word equation. So we shall say sodium plus water. Look at that. Sodium plus water. For your information, this is a word equation. And for you to understand how you can be able to do this in a better way going forward, you need first to have a clear understanding of what you're supposed to form when 2 reactants combine. So you have to ask yourself, when sodium combines with water, what are the possible end products? You see, when sodium combines with water, what are the possible end products? Sodium combines with water to possibly give us sodium hydroxide. No witchcraft can give you this product. You're supposed to actually know how you're supposed to end up knowing this product. You just need to put them at the back of your mind. So if you take sodium plus water, you can get sodium hydroxide plus hydrogen gas. In short, if you take a metal and you combine that metal with water, you are supposed to get metal hydroxide plus hydrogen gas So you'll get metal hydroxide plus hydrogen gas. So if you take a metal plus water, you get metal hydroxide plus hydrogen gas. An example of a metal, sodium. The water, and then the metal, sodium, then the hydroxide part, and then you have what you call the hydrogen gas. So sodium is capital N small a, the water is H2O. The products, you know, this is sodium, and you know the formula of hydroxide, which is a radical. Yeah, then plus hydrogen gas. You can balance this. How do you balance this? You have one sodium and you have as well one sodium. You have two hydrogen atoms, but you have two and then you have one. You have one oxygen, you have one oxygen. Hydrogen is not balanced. There are two here, but you have one here and then you have two here. So you need to ensure that whatever is not even must have actually end up getting made even. What do? You can put a number behind this. So you have two here. 2, that means 2Na. Then that means two hydrogens. How many are they? 2 plus 2, 4. So 2 hydrogens, then plus 2 hydrogens, 4. I'll put here 2 to make the number to also be 4. So 2 times 2, that is 4. Then how many oxygen atoms? 2 oxygen atoms. How many oxygen? 2 oxygen atoms. How many sodium? 2 sodium. Correct. And you're done. Write the state symbols. This is a solid, it's a metal. This is a liquid, water. This is aqueous, it's a hydroxide, a solution. Then this is a gas. Correct. Thank you for today.